Janes. Okay.
Okay, everyone. So for our next talk, we have Mark Janes, and he's going to talk about continuous integration stuff that he's been doing at Intel. So go ahead.
Thank you. Thanks, everyone, for coming. And thanks to my employer for sending me here. It's been a lot of fun. So in this talk, I want to discuss some of the continuous integration stuff we've been doing at Intel and let you know a little bit about myself and why I think continuous integration is effective and why it's been working for us. I want to describe some of the lessons that we've learned and things that have worked or not worked so well, and also just show you the test system that we have and maybe have a discussion about continuous integration in the large, because from my observation, it's a practice that's really all over the industry, but then at the same time, there are a lot of projects that have failed to take advantage of it effectively. So, I'm curious, out of the people here though, how many people actually have a CI system that they use every day or their team uses and it's really effective at finding out the bugs? Cool, all right. So it would be great to, talk with, there's some Intel guys with their hands up, but the other folks, are you all together in the same company or? No, great, cool. So we can have a good discussion about what your experiences are as well. All right, so I wanted to just initially take a look at the generic definition of continuous integration because I think that some people have a misinterpretation of what it's supposed to be doing. So Martin Fowler is a well-known author from the extreme programming camp, and he basically is pretty well known. And I think from this definition, the way I read it, it's clear that it's developers that are involved in this practice. I think there's a lot of work around automating tests that are not written by developers, where the tests aren't tightly integrated and coupled with the code. And I think that that's a key aspect that can lead to dysfunctional test systems. So the way he's talking about it here, each developer is working, finishes something up, and then submits it in the same day at the same time, right? And so since code and test are kind of integrated and tightly coupled, the developers are generally responsible for writing tests in tandem with their code. So yeah, there's a lot of room for disagreement about how tests should be done, what kind of tests should be done, but I want to focus more on tests that developers are writing and maintaining because I think that's the most effective practice for CI. So when you're talking about developer tests, why do people want to spend a lot of their time writing tests? Because it's not a particularly glamorous part of the job, right? I think in a lot of effective organizations, developers might spend 20 or 30% of their time exercising their code when they're done. And the reasons are because they want their project to be stable. A lot of times it's the tech leads for teams that are setting standards, and they want to make sure the team is successful, so they're setting a high bar for getting tests into their project because they want the project to succeed. But developers themselves, I think, once they start doing it, they find that, wow, I've uncovered 8 bugs that I didn't know about, and I wouldn't have known about if I hadn't spent a little bit of time just trying to drive through my code path that I've authored. So, but another good reason is that you might work on a feature that you think is really great and go and deploy it, and then 6 months down the road, some hacker comes along and changes something, and it breaks it completely, and it makes you look bad. So, but also, I think when you get to the point where you do have good test coverage, it's a much nicer job to have because you can push your patch out and feel confident that it's not going to blow up because maybe you've already fixed 12 bugs that the test framework has found for you. So, but some things that don't work as well, though, is when you have management or people who aren't developers really trying to force people to write tests because they think it's the right thing to do. If you can't encourage developers to do it on their own, then it's really hard to get them, you know, it's like trying to give a bath to your cat, you know, like you're going to have a pissed off cat and there's going to be blood. The cat might get clean at the end, but it's not going to be a practice that everybody has. I mean, the one in the upper left is going to really draw blood. Yeah, right, exactly. And I think I've seen this a lot where, you know, developers, you get a real uncooperative stance between developers and management. And it ends up not being a practice that works in the long run. So more ideally is where, you know, the developers are like, hey, I can do this stuff. I can do this massive refactor, and I'm confident that I'm going to make it across. I mean, this guy's manager is nervous, right? But, you know, but like, he knows he's not going to fall because he's been doing it a long time. He has the pull. He knows what works, right? So I think the people who really have adopted, you know, consistent test strategies in their normal development routine get to the point where, hey, I coded my happy path, and I tried to run it. Oh, it crashed. I fixed that bug. And then, OK, looks good. Maybe I'll push it. No, I'll write some tests. And then you find 12 more bugs, right? And by the time you get to the end of the process, you feel a lot better about sending it out. And over time, that value accrues. So yeah, and so I think this applies especially to open projects where, you know, there's not really a management structure a lot of times saying, okay, who's going to put the patch in or not. I mean, sometimes there is, but the developers are kind of independent, more independent, right? And so like this model where the developers are really testing their own work as part of their submission process, I think applies especially well in that domain. And also that whole, you know, situation where you might have your patch broken, right? So, okay. So suggestions on like effective practices for developer tests that I think if they're not done well, then your tests aren't going to be as good. And that the reason I want to point this out is because if you want to have an effective continuous integration system, it's really predicated on a very effective test system. And so if you haven't made an effective test regimen, then don't bother setting up automation around it because it's not going to give you the value you're hoping to find. So, so when you're thinking about, okay, how do I do tests well? I think sometimes people just write scripts or whatever and just try to call functions. And if you use a test framework, you get features. And a lot of times, if the test framework is well used, those features integrate nicely with a continuous integration system at the end. So you are able to filter tests and run a specific subset of tests, which is helpful if you want to run fast tests or slow tests. If you need to bisect in an automated way, this is absolutely a required feature. A lot of times test frameworks deliver XML output, which is easily parsed and displayed by common continuous integration systems, so you don't have to write that. Sometimes they provide process isolation, so if you have a crash, it doesn't wipe out 100,000 tests, it just affects the one test. So these are all things that a good framework can do. Sometimes it's necessary to write your own framework, and the Mesa team has written Piglit, which I think is a great example. But it's good to focus. Oh, yeah.
Can you speak up just a little bit, just on the edge of?
Oh, sure.
Of the,
Oh, okay, yeah, I'll try. Yeah, so the Mesa team wrote Piglit, which, you know, kind of reinvented some things that existed. But they also, you know, took the time to add the standard JUnit output features to Piglit so that we could use it with Jenkins, for example, right? Another thing is really making the test itself a first-class artifact of your development process, where, you know, as a developer, you might think, well, I have to get the feature done. That's my job. And if that's where your job stops, and you're trying to enforce test on a team, it's not good enough. I mean, the test needs to be as important as the product itself, and as well designed, because when tests are coupled with the code and the code changes, the tests need to change too. And so if you factored out something in your implementation, it's important to perform the same kind of thoughtful analysis on how to do that in your tests. And you can see this, I think, with the Piglit framework too, where you should learn how to how Piglit works, because then it makes your job a lot easier. And sometimes when you're prioritizing tests, just making your code available to be called by some second caller that's not your happy day scenario or the destination itself, it can decouple your code and make it so that it's more reusable in subsequent forms. And so with tests, I think it's really important to prioritize reliability and runtime, because those are the key characteristics that will determine how useful the test is in the future. If you have to run a test 10 times, how are you going to know if it's passing and failing? If the test takes an hour to finish, then you're not going to be able to run 1 million tests, because it'll be done in 40 years. So, but there are tests like that are commonly written. The most important thing for automated tests as the test suite grows is, what's the feedback loop? How long does it take for you to do your work and figure out if you broke something? All right, so once tests are, once you have a pretty good test system, then you can start to think about automating it. And there's a lot of ways that this can go off the rails and into the weeds as well. In a lot of ways, it's the same concerns. When you're running the CI, you really need to prioritize the reliability of the output of the CI and the runtime for exactly the same reasons. You're using this to run the developer test, and the developers are looking at the output. So I think it's really, if you're not doing this well when you don't have any developers that use your system, because they go and they see a bunch of broken tests, but they're not bugs, or they want to go run the test and it comes back 3 days later. But I think another thing that is a really key suggestion is, if you're going to have a pool of 50 machines, you want to automate the setup of all those machines and make it completely transparent. And so a colleague of mine, Dylan Baker, made a little thumb drive for us, and you just plug it in the machine and then we're done. So, and he's also set up a salt system, which simplifies the management of all those machines. So something else that is typically done wrong in CI is how branches are supported. So a lot of times people set up a bunch of automation in Jenkins or something to just build master, run the tests, tell me what broke. And then when you cut the stable release, you just take the whole CI project and clone it, right? And then have it keep running on the stable release. And that doesn't work as well, because your automation may change as it goes forward, and you add new features or new projects, but the stable branch that you have in your continuous integration system is no longer compatible with your automation, right? And so, and also you might be tracking passes and fails in your CI, and those things will get out of date on branches. So it's good to consider how your team branches and how to unify branch handling in your system. And I think that actually a lot of CI tools don't really do a great job of this in my experience. So another thing is that there's going to be a lot of technology choices for your continuous integration when you're, so okay, are we going to use Jenkins or BuildBot, or are we going to use something else? I was on a team that went through 4 different CI systems in 6 months. And so, because people will this is my favorite thing, and you'll end up implementing 2 because people can't agree. And so if you're going to write automation to drive your build, execute your code, and run your tests, or filter them or handle them, it's good to make that relatively independent of the whatever web interface you're using. And a side effect of that is that if you've made it sufficiently independent, you can also run it on your desktop and debug it and find problems with your own automation. So I think another part of that is to really keep your automation in revision control. This is another thing that CI packages often do wrong, is you're setting up your project in a web interface, and it goes into some database, and then somebody goes in, logs in, changes it, and what changed you don't know, right? And so it's really good to keep as much of your automation in your own Git repository, and when possible, keep your CI itself revision controlled. And Jenkins in particular does a really good job with this because they have XML files that run the configuration, and you can check those in. So, but that's another key place where people screw up. Okay, so another thing is that sometimes when you have, there's going to be bugs, there's going to be fixes, and tests are going to break. And I think there's a philosophy where it's like, we want to know what's our overall pass rate, right? So you might have a 70% pass rate, and that's what your CI shows. But that's really not that helpful if you do it that way, because when a developer wants to check a change that he or she's been working on, they go and run their branch and see 70.1% pass, right? And it's hard to eliminate things that are known defects from the deltas that the people are seeing in their branches. So it's good to identify regressions, write them up as bugs, track those in Bugzilla or whatever your bug system is, and then make the build green again by basically accepting that that's a regression. So, okay, so I want to show you our Jenkins lab, or our continuous integration lab that we've built up here. Right, that's not it. So, so we just took some commodity motherboards. We stole laptops out of people's desks. People were contributing their home systems, and there's about 50 systems here lined up. And I think the average cost is probably $200 or $300 a system for the 1U, 2U systems, and the laptops are free. People are throwing them away. So if you want to build up a pretty big system, you can get it into a small, area with not much work, and get a pretty reliable system out of it. It's not that hard to do. Okay, so I want to show you the Jenkins instance that we run on top of that, and kind of go over some of the features, how we support developer branches, the stable branches, how we let people fire off their own builds to check things that maybe aren't supported by the standard for check-ins, how we summarize things, and we have a long poll analysis thing built into it as well. So let me see if I can.
Before we get started again.
Yeah, sure.
Somebody could close that door before another wave of students comes by.
Okay, sure. All right. Oh, come on. That's not going to work, is it? All right. So, okay, that's too big. Okay. So, this is our Jenkins instance. I think a lot of you have seen Jenkins before. But these, on the front page, we track daily builds, which have, they select platforms which are too slow to complete in 20 minutes. And then the master branch, which is the same thing, but excluding the slow platforms. We also run on the stable branches as well. And if you want to, let's see, here's a daily branch. Across our machines, we're hitting almost 700K tests now. And I never thought we'd kind of get to the point where Jenkins would start to struggle with the test count, but there are things you can do in the UI that'll cause it to run out of 256 gigs of memory. So yeah, we have 4 failures out of 700,000, right? That's the consistency level that you need to get to in your unit tests if you want to be able to run across a wide set of systems. And even these, my task is to get it to 0. So if you go into one of the tests, we kind of summarize the SHAs that everything was built with, and then each build is broken up into a bunch of components which either build or compile, and after each one finishes, it puts its results into an NFS, a shared NFS directory, and then subsequent builds take off. So we have a whole bunch of things. We just deployed dEQP, which has greatly expanded our coverage and has been pretty reliable, but that's one of the things we have intermittent tests with, is trying to figure out which ones in dEQP really are not satisfactory. One of the things we do, so on Bay Trail, we shard out the dEQP tests to a wide, to 7 systems at a time so that they can complete fast enough. And so that was a feature that we added into Piglit, and that's one way we get the job done. So, but we compile DRM and Mesa and Piglit, and then we run Piglit tests on everything back to G33 and Iron Lake, and across the various SKUs for hardware, and 32-bit and 64-bit. So it gets to be a pretty big matrix, and it's finishing in an hour for if you include Bay Trail, but you leave those ones out, and it's finishing in 20 minutes. So yeah, so Braswell had a failed test, and that's another thing we did, is we deployed a bunch of Braswells, and we had to figure out some of the instability in those systems. So here's a little table that lets you figure out why was this slow. And so you can see the longest one was running, one of the Piglit tests was 44 minutes, but it was waiting for a machine for 20. And so I already know why that is. It's running on Bay Trail, and we have a couple of Bay Trails on order, so so all the dailies can't run at the same time. All right. So the nice thing about using Jenkins and not writing your own thing is that you get a lot of automatic summaries, and sort of tells you how old test failures are, and you can click on a test and it'll tell you the output. It's like, why did this fail? And this is a dEQP test, which is testing something that we don't want to test, and so I have to go say don't run this test anymore, because we run them in parallel to finish on time, and I think performance tests in dEQP, you really need to run them serially if you want to get a stable result. So from the front page, there's a developers tab, and so all the people sort of that are behind the Intel firewall have little projects, and so they just push to their remote, and it'll start a build, and then they can go check the results later. So Nanley's having some trouble. I shouldn't show you what people are working on, because it's maybe there's a million broken tests, and they're just trying stuff, right? So. Okay, yeah, so that's basically the CI instance. But I think the key thing to take away is a lot of machines, a lot of tests, finishing in 20 minutes, and reliable, right? Yeah.
One of my experiences, it sort of goes back to what you were saying in the beginning with managers being stupid. We had.
I didn't say that. We have a great manager.
I was paraphrasing.
My manager is one of the best managers I've had in a very long time, and
yeah, but the bar's so low.
If you have bad. So. Hey man, you don't know how bad it can get. Well, yeah.
I've been around for a while. So. I don't think it's strictly that you need a lot of tests that run fast. The tests still have to be very useful. And I've had cases where we've had like 100,000 tests, each one more useless than the next, and you get green bubble and 100,000 passes and nothing actually works.
Right, and
So I just wanted to clarify.
Okay, yeah, but that's if this is coming from the developers, themselves, then it's their own fault, right? And so the task is kind of on all of us as we work on our products to come up with the most thoughtful strategy for exercising our code and eliminating things. I mean, you might have tests which are fragile. Hey, I found this cool thing. I used canned data and I kick it into my process and it hits the thing I want. But then every time you change a struct, the canned data is out of date, right? And so you need to figure out how to make an extensible format for your canned data or some way to generate the canned data from something that's not going to go out of, you know what I mean? It takes design, it takes experience, and a lot of times I've been wrong, you know.
I just think it's a pitfall to say,
Yeah.
I have 700,000 tests, so you're...
Okay, yeah, and I apologize for that. I did the same thing that like other people who are proud of their system do, which is like, look at my 700,000 tests, you know, like, you know, right? Yeah, I did make one test which it, like randomly adds 1 + 1 100,000 times just to try to bump it up a little bit. So, yeah, so make sure that pass works. That's my thing. Okay, so let me see. Where am I? Okay. Okay, so I kind of, I don't know how interesting this is going to be for you guys, but I do want to just describe the automation a little bit and to give you some ideas of how I structured this. And it's all on GitHub, and the scripts are there, but it's it's scripts, right? So you can write your own. But I think sometimes the concepts translate well. So the way that this was laid out was to break up the arbitrary build and test system into a bunch of components, which have a standard interface and a limited interface, and then have kind of a scheduler which stacks them together and builds the test system you want. And that's a really flexible approach because you can fit almost anything into a little tiny script that just says clean, build, and test. Those are the things you do, but on 64-bit or 32-bit architecture or with this hardware platform, so like you can specify a limited set of options to a component. And the nice thing about that is then in your CI, you have one project and all it does is build components. And your scheduler will just fire off all those component builds in parallel. And as they finish, send the next builds which are dependent. So, I mean, we'll fire off DRM for both architectures and for our 64-bit and 32-bit in parallel at the same time as our scans build test to verify we didn't break scans. And if there's maybe somebody pushed something and it broke gallium, and you're mad about that, then you can just make another build test for gallium and deploy that as a component as well, and it gets added to the matrix for low cost, right? Right. So yeah. So let me just go to the GitHub project. So one thing, I mean, it's not that many scripts at this point, but there's a wiki over here. I think that's important to really document what you're doing. Sorry, it's not really displaying very well, is it? So one of the key things to document really well is how you set up your master, because that's one of the things that will limit the reproducibility of your system. And so, we teamed the NICs to get a lot of NFS throughput, and we set up a RAID 0 and just all these different mount points, and it's good to just have something. So you should take someone from your team and say, hey, can you make another one of these systems based on my documentation, and find all the holes. But the other things, so the scripts are really controlled by it's just an XML file. You guys can do whatever you want, but in this automation, we basically just define projects like DRM and Mesa and list prerequisites so that the scheduler can know what has to build in what order. And then you might specify a project that does all the tests, and it will run Piglit on a wide variety of hardware, and also Braswell and Bay Trail on a daily basis. And so you can just set up a little set of dependencies and then have a scheduler script to read these. So Jenkins is really nice if you want to do this because Jenkins has a Python REST API, so you can fire off a build from Python, you can check its status, you can wait for it to finish. And so Jenkins also has build flow and matrix builds and other types of build sequence plugins that you can use. But once you go and do that, then a lot more of your system is in Jenkins as opposed to in your own scripts, right? So I think it's nice to use Jenkins for what it's reliable, showing results, controlling builds, but like keep as much as you can in your own automation. Because then you can run this whole same set of sequences and projects you can just run on your desktop. Another thing further down in the build specification is the list of remotes that are going to be pulled, right? So that's also happening outside of Jenkins. So if somebody wants to put another remote up and have it kick off builds, then we just add it here and then it'll work. So each component is just basically a subdirectory with a little build script. And there's some helper functions, but it basically boils down to customize any options that are specific for this build. Maybe list out the G tests, so those can be executed by the runner and exported into the CI at the end. And then have your auto builder run build, which is just configure, make check, and then you have your G tests, right? So that's just the way this is particularly laid out. So each project is a subdirectory. And then I think maybe one other interesting one to look at is Piglit. So we build Piglit in Piglit, and then we test Piglit in this one. So in this subdirectory, there's also a bunch of configuration files. And this was effective for us. I don't know if there's a bunch of ways to handle this particular problem. But to keep the build green, we added a feature to Piglit so that it can process known failures and say, hey, this is an expected failure, and it'll give it a pass instead. And so you list out your tests, and then also the same thing for crashes, expected crashes. But it became apparent to us that updating these files on a regular basis was painful, so I built some automation to do it, and the automated process actually includes the SHA there with the test. So when it broke, what broke it, when it's fixed, what fixed it, and that's the sort of the key implementation that allows us to deal with branches effectively, because Ben over here may want to test his new feature. He hasn't rebased it in the last 24 hours, and tests were fixed by other people during that time. So they would show up as failures in his branch because, hey, somebody fixed this, but it's broken. But because the SHAs are here, when Ben runs his tests, it'll find the branch point for his branch and then look up beyond the branch point and then filter out anything that changed status during that time. So that's the way we kind of handle that's how we handle all the branches. And the other nice thing about this, though, is because we're doing this on a consistent basis, when we go to build a stable branch and release it, this is one of the first times we've gotten a stable branch out with no dEQP regressions. So this is a really important history to have, because you can go and figure out what you need to backport and to fix the tests in your stable branch, if it's even possible. Let me see. Oh, just really quickly, there's the build support directory in this project is where we kind of have our automation, and so the dependency graph is the things that reads that build specification and figures out what builds can run. The Jenkins module just knows how to fire off builds on Jenkins and wait for them. And so you kind of string those things together, and then you can drive the system. So, okay, I think that's probably enough about that. So let me come back here. I mean, is that useful or don't tell me. Okay. All right. So I just wanted to relate the system we've built to some of the suggestions and what Mesa is doing that works really well. So in terms of reliability, reliability of the test results, filtering the tests that are unstable out. That's something that the Piglit component does. It just says, on Sandy Bridge, I can't run this test, and it doesn't do it. So, I mean, there's some, there's some timer tests, for example, and they pass most of the time, but if you're running in parallel, they'll fail a bunch. And so we just can't run them, right? Process isolation in Piglit is another key way that we get reliability because when the tests crash, we still get good results. Sharding the tests between machines is something that really improves the runtime. That long pole table helps you analyze what's slow. And having the tests platforms segregated in a way where you have slow daily tests and fast per check-in tests. That's a key way to focus on the runtime. Daily tests, daily tests are great because you can still run slow tests, but they stink because every time you have a test failure on your daily test, you have to bisect it, right? And so, again, it's back to the faster you can make the tests, the more useful they'll be and the more time they're going to save for people. So automated machine setup, one thing I didn't show you guys is there's also a GitHub repository for our salt. So if you want to see how we set up our machines, it's there as well. And then the branch support, we talked about how we track everything by SHA. Another thing I didn't mention about branch support, though, is so because most of our configuration is in Git, it too can be branched. So what you'll see a lot of times with CI is people will say, hey, I want to change my CI and fix it. I need to add a feature. And they'll go and they'll make some new project, and then the whole system will crash because they tested it on the production CI system, right? Or you might see someone who's like, I have two different Jenkins instances. One which is my production Jenkins instance, and the other one is the one which I go and change my Jenkins builds to try to figure it out. So that kind of stinks. And so when you keep your automation in Git separately from your Jenkins instance, you can make a branch and test it in a custom build to see that it works and roll it out in a smoother way. So, yeah. So, I think the standard tools and the tool neutrality we talked about a little bit. I think though, in making tool choices for this kind of stuff, my rule of thumb, I don't know if I'd like to hear what you guys think, but my rule of thumb is choose the tool that has the most users generally, because that's the one that's going to have the fewest bugs. And if there's any reason you have for not doing that, choose the tool which has the most significant uptake and is growing the fastest, right? Because maybe Bugzilla is used by everybody, but they have something new which is even better, and people are jumping ship. So, right, and bug tracking and regression identification. One thing I didn't show you there is that if you go to the bottom of the builds, where do I have one? Oh, okay. I'm going to have to click a link and hope the network works. So, so we had a failure on master 2 hours ago, and I hope my VPN is working. Oh yeah, okay, sorry. Down at the bottom, there's these links that are automated. And so if you want to kick off a bisection for this particular test suite failure, and these are, okay, so we got a GPU hang on G965, and that caused a couple of other G965 tests to fail. And then we have a functional flush finish weight failure in dEQP, which is, we just enabled dEQP, and this is an unreliable test that I need to turn off. So, but I could say, hey, I could click on this link and it will update all the config files and send me a patch based on those. Or if I'm not sure, because it's a daily build, what revision is responsible, I can bisect it in Mesa or in Piglit to figure out what it is. So that's kind of a nice little feature. All right, so okay, so one thing I'd like to know, though, is especially from the folks who raised their hands, you know, said they had an effective CI system. What do you guys think is like some of the common pitfalls that people make? Some of the mistakes that they do when they're setting up a system, maybe that I didn't enumerate.
Well, I'll say the opposite, or you can interpret it as a pitfall if you take the inverse of what I say. The best thing that we did was bring you onto the team so that we can work directly with you and not have this insular QA team somewhere else that we would throw requests over the wall.
Absolutely.
I've had several things where I'll ask you, hey, can you add this? And within the day, like most recently I think was emailing me results. Like,
Sure.
And I didn't have to put in a request. I didn't have to deal with your manager's priorities. It was like, Mark, I need this. Can you add this? And if the answer was no, you told me why not. So I think having that integrated into the team has been the best move that we've made QA-wise.
Yeah, I totally agree. I think that there's a really typical separation between some of the quality processes in companies and the development processes in companies. And because of the way those jobs had different statuses, you know, like in the 90s, right? You know, like you had your rock stars on the development team and the QA team, you would just, you know, put all the people who couldn't succeed as developers maybe sometimes. And that was an old paradigm, and it still exists, I think, in companies where you have the same managers 20 years later, right? Newer companies, you go to a startup and they don't have a separate quality team a lot of times, right? I mean, that's where I was when I was working at a company with 20 engineers. We were responsible for the quality, and that's part of the reason why I got interested in this stuff, because it was, you know, my butt on the line, and it makes a difference, right? You make different decisions as a developer, and it ends up being a lot more functional in the long run. So, yeah. Does anybody else have any? Yeah.
I was going to say that one of the pitfalls is not making the CI a standard part of your development process.
Yeah.
So in Canonical, we have it integrated into Launch. Sorry, in Canonical we have Jenkins integrated into Launchpad, and while it's not 100% enabled by default, basically all our projects immediately have it. So when you do a merge proposal, Jenkins kicks in, builds the packages, runs any tests.
Yeah.
And by having it there by default means that everyone uses it because it's there. You don't have to go and go, okay, now we need to think about adding Jenkins and delaying it. When you start a project, it's basically there.
Yeah, I agree, yeah. I think one thing, though, to consider before you force a process down is it producing noise or is it producing signal, right? I mean, yesterday we had, I'm sorry, what was your name? Matt from Micron talk about how they gate check-ins based on this process. And you can imagine how frustrating it would be if you're trying to submit something and it's not going to even get to the CI until 2 hours from now when the previous submissions finish. And then when it finishes 40 minutes later, it kicked it out because no good reason, right? So it really, you have to have, I mean, I wouldn't even have it send email yet because there's still those 4 failed tests, right? And who wants to get an email, right? I mean, every false positive, I think you should think of it as like, is this adding value or taking away value, right? And when you have false positives, it's worse than nothing.
So that's part of the value of having it there by default. When you start a project and you have 0 tests, it passes. So
everything passes.
As you add the tests, they all have to pass by definition.
I don't know,
so
0 over 0 is 100%, I think.
But you don't get the point where you've got like halfway through a project with 100 tests, and then you go, oh, now we'll enable CI. Oh, we only
Yeah.
get 80% pass rate.
Yeah.
We'll fix those one day,
Yeah.
and you never quite
you know,
get
we
there.
actually have part of the Mesa team's working on a new project, and they have been writing some automated tests, but they didn't have the CI there to begin with, and everybody's kind of like working, but then somebody turns around like, well, the good news is some tests pass. You know, the bad news is a lot of, you know, where half of them are failing. Right? That was an email last night. I mean, the email you want to see is like, hold on. I mean, this is the email I got from Jason Ekstrand like just this morning. I mean, I just woke up, I was like, oh, okay, hey, look, this thing failed on Sandy Bridge. And like, he just pushed it the night before. So he's like, oh, I know what's going on, right? So he's already figured it out. If this happened when we were going to push a stable branch a month from now, there'd be a bisect, there'd be bugs. It's just a huge mess, right? So it's just way more efficient to get that feedback to the person efficiently and quickly and painlessly. So, yeah, okay, we have somebody.
This all sounds very important and good. I'm not speaking against it. I just say there still should be a room for QA people who are your opponents, not your friends.
Yes, yeah, and I totally agree with that, right? And I think that's the thing about you don't want to be exclusive with your strategies, right? You want to do everything that works. And one thing about developer tests is you're really trusting the developers a lot, and sometimes they don't deserve that trust. At OTC, they're great, right? You know, like so. It's a really strong team. Yeah, right. But sometimes you need somebody who basically wins by finding the bugs instead of wins by reporting 700,000 green tests, right? I think that matters in a big way. And I think also, so this is for finding regressions, but if you want to validate that you meet the acceptance criteria, that's a completely different set of tests, right? It's not something you would do in an automated way, and you wouldn't trust the developers to do that either, right? You would say, oh, okay, like Google, they bought a dEQP draw elements to make a validation suite, and it's an external suite, and we just have to meet it. You know, the GL conformance test, right? It's another example.
And that's also where you have room for the 2-hour tests.
Exactly, right. It doesn't have to be fast. It needs to test everything, right? Yeah. So, anybody else like had disasters or great success?
Yeah, I just wanted to mention the LLDB project's experience. I do work with it's the debugger in the LLVM family of tools, and I think what the experience from that shows is really reiterating your point about having the tests as a first-class citizen during the development process. Some of the tests were of varying quality, hadn't been run in quite a while, and were intermittent and things like that. And that's still the case, right? To the extent that you have sort of an expected failure decorator that you'll put on tests as once the defect is submitted, you'll mark the test as expected fail until it's fixed.
Yeah.
But there are a number of tests that are sort of so intermittent that there's also in LLDB an expected flaky decorator, and so a whole bunch of tests are annotated as saying this fails sometimes, and if it does, rerun it up to 3 times and see if it passes.
Right.
And I mean, it's in some ways it's good in that getting the build bot to green and keeping track of new regressions is very important, but it also I think introduces some behavior that you want to try and avoid, and making sure that you consider that from the very beginning is very important.
I think too, if you have a flaky test, you need to have that expert knowledge to say, is the test poorly written, or am I testing something that's flaky in our implementation, right? And if in fact what you're finding is that test after test is flaky, or you spend more time working on the test than you do on the product itself, then the tests are not adding value, they're taking away value, right? And so it means you're not putting sufficient thought and effort into doing a good job with testing, or maybe just like the person who worked on that test is not isn't there yet, right? Needs to improve what they're doing, right? So, one other thing I wanted to know is that, so this has been really effective for the Mesa team. We're shipping stable releases, and we already know what we need to backport, and it's the developers use it on their own volition without being forced. And so we have other people outside of the firewall that also, want to test on Intel hardware or on other hardware. And so I'm not sure exactly the best way to share this, or, I can build anybody's remote and run it and send you email later. But I don't really know. Like, are there other people who would find value in this type of setup to run Piglit and dEQP specifically?
Yes, I was going to ask if I'm a random contributor. If I'm a random contributor and I come up with a branch, I don't get this feature, right? Unless you whitelist me into.
Yeah, unless I put your remote there and,
Yeah.
and set up a project to send you email when it's done. You won't be able to see the UI because, I haven't really locked it down at all. Anybody could go and delete a project, right?
Yeah.
So, but that's a problem that if there are people who want to, we can improve that or find some way to expose it in a read-only way. For example, I don't know, and that's one of my questions is specific. So this is Mesa and dEQP. Piglit, right? Are there others who need to do that?
Yeah, so we have a similar challenge at Canonical. So if I make a merge proposal to LightDM, it will run the tests. But if anyone else does it, it doesn't, because the tests are not sufficiently sandboxed that we can trust everyone.
Yeah, exactly, right.
So we whitelist people that we know, but
Yeah.
it would be awesome for us if anyone who did a merge proposal would just say pass or fail. And the same thing, if I had a bug fix for an Intel driver, I could do some sort of merge proposal to you guys, and that would just tell me automatically, your stuff's crap, you need to fix it, or,
Yeah, right. And you do have to be a little bit thoughtful about the utilization. You say, hey, I'm going to kick off all these builds, and I'm just going to kick off 1,000 builds, and you don't, someone's hogging the machine that, we have 50 machines across, I don't know, a dozen platforms, right? So you need to be a little bit careful. But I think that there's room for that, frankly. Or somebody, I think this instance, if somebody wants to solve the same problem, it's all documented and available, so anybody can set it up. Do you guys have any other questions or thoughts? All right, well, thanks for listening to me.